Hi everyone. In my today's session, I'm going to cover the topic of generic type constraints in C sharp. Okay, so basically putting some constraints over the generic types which we are going to use in our generic definitions. So let's go through that. Okay, the where clause in a generic definition specifies constraints on the types that are used as arguments for type parameters in a generic type, method, delegate, or a local function. Constraints can specify interfaces, base classes, or require a generic type to be a reference or a value or an unmanaged type. Okay. They declare capabilities that the type argument must have and must be placed after any declared base class or implemented interfaces. So one such good example is say you can declare a generic class employee such that the type parameter t implements the I equatable interface like this. Okay, so public class employee of t where t should be equatable. So whatever class basically you pass over here when you create an object of this employee class, right, that class should implement interface equatable. Okay, if it doesn't implement this I equatable of t interface, then it will return a compiler error. So let me show you that quickly. So in simple words, I create a class, public class employee of t. Okay, generic type parameter is t, where I will put the constraints. See the syntax, guys. Public class employee of t, where, okay, then you specify your generic type parameter t colon, using colon you will specify. Okay, so what interface it should implement or what base class it should inherit from. Okay, so I created a simple employee of t class, and then I created a public class department which doesn't implement the interface I equatable of t. Now I try to create an object of employee department. Okay, emp equal to new employee of department. See what is the error. The type pangram.department cannot be used as a type parameter t. In the generic type or method employee of t, there is no implicit reference conversion from pangram.department to system.iEquatable. Okay, so at the compile time itself you will get error. This ensures basically this adds additional feature of type safety. Basically your generics concept itself implements or provides a type safety feature, but this is an additional type safety you are allowing to your generic types by providing this kind of constraint. So that's the power of uh, C sharp generic type constraints. Okay, where clause can also include a base class constraint. Okay, so yes, the way how you specify that this t should implement a equatable of t interface, in the same way you can specify that the t should inherit from a base class. So let me show you that quickly. So very simple, I created an abstract class. So it may be a normal class or abstract class. So I created an employee base which has only one property int id, and I specified that public class employee of t where t colon employee base. Okay, then what I did, I created a class, public class department. Now see, employee of department emp equal to new employee of department. Again, an error. So it complains that department doesn't inherit from the base class employee base, or you can say entity base. Okay, so entity base. Let's make it entity base, and same we will apply over here. Yeah, now it makes sense. Okay, because these are entities basically, employees and departments. So that's the error. So you can basically perform basically you can specify the base class constraints also in your type parameter. Okay, so let's move on. So the base class constraint states that a type to be used as a type argument for that generic type has a specified class as a base class, or is that a base class itself. Okay, if the base class constraint is used, it must appear before any other constraints on that type parameter. Remember this, guys. Okay, so if I'm using multiple constraints on this particular type parameter, right, then the base class constraint should always come first in the list. Okay, there are other constraints, like I can specify it should contain a parameterless constructor. It's a mandatory. Okay, this type t parameter should have a parameterless constructor, or the, yeah, the default constructor. So if I specify this, no, if there is a list of constraints I'm specifying with a comma separated, then the base class constraint should be the first one. Okay, otherwise it is a compile time error. Okay, so that's uh, all about it. As you can see, now it is complaining. Okay, the new constraint must be the last constraint specified. Okay, so the base class should be the first always. Let's move on now further. Mm, yeah, yeah. Some types are disallowed as base class constraints. Yes, there are some types which you can't use in the constraints. Okay, the way how we were using here, right? Like entity base, I disposable interfaces. In the same way, there are built-in classes like object, because every class in C sharp, okay, indirectly they will inherit from object itself, the system dot object class itself. So no need to specify that. That's why they have disallowed. And then array, yes, that is also not allowed. And value type, okay, in order to achieve this, I'm going to explain soon. You can basically specify a type constraint for a struct. Okay, you can't use the value type base class directly, but you can specify the struct in order to make the type parameter to be a value type. Okay, so some examples: public class state a strategy of t where t colon system dot enum. So the type parameter should be an enumeration. Okay, public class my app delegate, so my custom delegate t where t colon system dot delegate. Okay, so it should inherit from the delegate base class. And then public class message broadcast handler of t where t should inherit from system dot multicast delegate. So these are some examples. In a nullable context, the nullability of the base class type is enforced. Okay, so when you are using nullable types, right, nullable type parameters, okay, so the nullability of the base class type is enforced basically. So if the base class is non-nullable, for example, okay, there is some base class called base, it is not nullable, the type argument must be non-nullable. Okay, so it should be just a t. Okay, here if t is, the base class is non-nullable, the entity base is non-nullable, then t should also be non-nullable. Okay, so you have to just mention it as a t basically. Okay, or something like this, t colon class. Yeah, like this you have to specify. Okay, if the base class is nullable, the type argument may be either a nullable or a non-nullable reference type. Okay, so if the base class itself is nullable, then yes, you have to specify the type argument may be either as a nullable or a non-nullable reference type. Okay, the compiler issues a warning if the type argument is a nullable reference type when the base class is non-nullable. Okay, so it's a warning, it's not an error. The where clause can specify that the type is a class or struct. Okay, so that provision has been provided. So you basically specify that the type should be a class. Okay, here we were previously we were specifically specifying the class names like entity base, interface, like that. But now we have a mechanism where I can specify that my type should be a class. That's it, whatever class it may be. That's it. If you specify like this, then any t which you are using, okay, see the error has gone now because department is a class basically. Okay, and yeah, it may be struct also, so you can specify it as a struct also. So let me show you that example of how here, or let's put a struct itself here. So if you make it struct, then you will get an error. See, because department is not a struct. Okay, the department must be a non-nullable value type. Okay, in order to use it as a parameter, so you will immediately get a compile time error. The struct constraint removes the need to specify the base class constraint of system.value type, as I already specified. As C sharp doesn't allow you to use system.value type in constraint, in that generic type constraints, you can't use it as a type to specify that. So you can basically make use of the keyword struct. The system.value type may not be used as base class constraint. Okay, so one example: class my class c comma s, where c is a class, s is a struct. Okay, in a nullable context, the class constraint requires a type to be a non-nullable reference type. So okay, in a nullable context, the class constraint requires a type to be a non-nullable, okay, reference type. To allow nullable reference types, use the class question mark constraint, which allows both nullable and non-nullable reference types. Okay, so that's all about nullable contexts basically. So in a nullable context, the class constraint requires a type to be non-nullable. So if you specify just a class here like this, okay. So public class employee of t where t colon class, then it's a non-nullable basically. And if you specify a question mark, then it's a nullable. So you can give, you can use the types which are basically nullable in nature, and null can be assigned. Okay. The where clause may include the not null constraint. Okay. Yeah, the where clause can make use of the not null constraint. The not null constraint limits the type parameter to non-nullable types. So if you go to the where clause, you can specify t being a not null. Okay. S- that's it. Okay. So basically your t cannot be a nullable type here. Okay. So the not null constraints limits the type parameter to non-nullable types. The type may be a value type or a non-nullable reference type. Okay. The not null constraint is available for code compiled in a nullable enable context. There is a feature of enabling nullable context using the regions basically. Hash nullable enable equal to true, and then you can using the hash region you can make it to reset. Okay. So there is a construct that you can make use of. Unlike other constraints, if a type argument violates the not null constraint, the compiler generates a warning instead of an error. So warnings are only generated in a nullable enable context. The addition of nullable reference types introduces a potential ambiguity in the meaning of t question mark in generic methods. Okay, so if you are using some generic methods and if you use t question mark and if you add the nullable reference types, okay, if you add the nullable reference type, then there is always a potential ambiguity. Okay, and it is a solution also to get rid of that. Okay, if t is a struct, which is a value type, and t question mark is same as basically system dot nullable of t. However, if t is a reference type, then t question mark means that null is a valid value here because t is basically what? It is a class. If t is a reference type, that means if t is a class, then does it make sense to add a question mark because classes are reference types basically. Okay, and null is valid value here. The ambiguity arises because overriding methods can't include constraints. Okay, the new default constraint resolve this ambiguity. Okay, there is a keyword default using which we can basically avoid this ambiguity. So you will add it when a base class or interface declares two overloads of a method, one that specifies the struct constraint and one that doesn't have either a struct or a class constraint applied. So this is the example: public abstract class entity base. See the methods: get created date. Okay, public void get created date of t question mark item where t colon struct. Very clear. Okay, type should be a struct and it can be nullable. But look at the other method: public abstract void get created date t question mark item. So t is already, they have not specified as a struct, so default is class. So t is already a nullable type, so t question mark doesn't make any sense, right? So the solution is default constraint to specify that your derived class overrides the method without the constraint in your derived class. Okay, or explicit interface implementation. It's only valid on methods that override base methods, okay, or explicit interface implementations. Okay, so what is the solution? Very simple. So when you derive uh, when you use this derived class person, which basically inherits your entity base, this one, okay, which provides two same methods basically, and one is having a type constraint of t colon struct and other doesn't have anything but has a nullable type in the type parameter. Okay, so what you can do is public override void get created date. You are overriding this abstract method. So public override void get created date t question mark item where t colon default. Okay, so default means if you are not specifically specified any struct or anything, then it will goes to class type basically. Okay, so where clause may also include the where. Okay, so without the default constraint, sorry, I jumped on next point. Without the default constraint, the compiler tries to override the first method in entity base. See, if you don't put the default, then what happens is when you override, right, it won't override this abstract method, but it will try to override this method which is of type t having struct. No, I don't want that. Okay, if I have not specified uh, any kind of constraint for t, like whether it should be a value type or reference type, if I have not specified whether it's a value type or reference type, then default it should fall back to reference type, which is a class, right? So you have to make use of default, that is t colon default. Okay, while overriding, do remember this. Where clause may also include an unmanaged constraint. Okay, The unmanaged constraint limits the type parameter to types known as unmanaged types. Okay, this is a special kind of constraint, guys, in C sharp generics, which deals with the unmanaged types. Unmanaged types means which are written in which are basically written in a C or C++ kind of programming languages, which are the binaries basically. Okay, and sometimes they are also called com components. Okay, so there is also provision provided for you that you can basically make use of unmanaged constraint on the type parameter in order to do some additional functionality on your unmanaged types. Okay, so the unmanaged constraints makes it easier to write a low level interop code in C sharp. Okay, this constraint enables reusable routines across all unmanageable types. The unmanaged constraint can't be combined with the class or struct constraint. Do remember this. You can't combine unmanaged constraint, okay, with a type or struct like this. Okay. So if I use class, okay, struct, then unmanaged. So the moment I put unmanaged, see, the class struct unmanaged, not null, and default constraint cannot be combined or duplicated and must be specified first in the constraint list. Okay. So that's what. When it comes to unmanaged constraint, you can't combine both of them. Okay, class or struct. The unmanaged constraint enforces that the type must be a struct. That's it. Okay. So if you have a class unmanaged com component of t, where t colon unmanaged means this t is always a structure type or a value type. Okay, you can't work with unmanaged type. Sorry, reference types like classes basically. The where clause may also include a constructor constraint, which is a new, okay, a new keyword only, accompanied by opening and closing brackets. Okay, so that constraint makes it possible to create an instance of a type parameter using a new operator, using a default constructor, you can see. The new constraint lets the compiler know that any type argument supplied must have an accessible parameterless constructor. Very simple. So public class dimension of t, where t colon I comparable of t comma new. Okay, so the meaning of using this constraint is that t item equal to new t of t. That means the type whatever you are passing should have a parameterless constructor. Okay, and this should be last in the constraints conditions. Basically whatever constraints you specify for a type, right, the new should come in the last basically. The new constraint appears last in the where clause. Okay, the new constraint can't be combined with the struct or unmanaged constraint. See, you can't make use of this new constraint with structure or unmanaged constraints. Okay, so it should be with class types or reference types. All types satisfying those constraints must have an accessible parameterless constructor, making the new constraint redundant. Okay, so let me quickly check that. So put this class, and now I will try to apply the new. Let's see what happens. First I will try to apply new on a struct. Sorry, new. See, it's an error basically. Okay, the new constraint cannot be used with the struct constraint. Okay, so you must make use of it with classes basically. Okay, the error is gone. All types satisfying those constraints must have an accessible parameterless constructor, making the new constraint redundant. Okay, with multiple type parameters, use one where clause for each type parameter. So if you are making use of multiple type parameters like this class dictionary t key comma t value, so you can use multiple where clauses or one where clause per each type parameter. See, for tk, where t key colon, you can specify the constraints, and for t val you can specify one more constraint using where. So where t val colon my interface, so it should implement from some interface. Type constraints can be attached to methods and delegates. Very simple. So this is already shown. Public void process workflow of t. This is a method basically. So okay, process workflow of t. Okay, where t colon I disposable. It should be a disposable. It should implement I disposable interface. Delegate t set state of t. Okay, where t colon new, it should have a default constructor. So this is a very good practice, guys. Basically whenever you specify some base classes in your application, in your initial design you usually come up with some base classes, like in entity framework core sometimes you specify the entity base. Okay, and also in your application domain or business domain itself you specify some base classes like employee base. So in such scenarios you can specify this kind of type constraints, so which basically safeguards your types being used by developers when they write their code. And it will basically make you, or it will basically provide the adherence to these rules set on your base types. Okay, so basically using this generic type constraints, you are specifying, or you are basically providing some strict rules that this should be, the type parameter should comply to all these rules. Okay, if anybody violates that, so eventually they will end up with compile time errors. So this is a good practice, and I hope this will be useful for you people. And thank you for listening, guys. Okay, have a nice day.